did make that plot so you could see what it was doing, and confirm that it was correct. But you did not have to make that plot, so you can keep on going down. The next thing is where keep on going down. That thing where it does mu of nt. That's the thing that you need.
Is there another one that we need as well? Or is it just this is the inverse that we need?
That's the. I mean, you need to define n, so you're going to need that. One of the steps up above defines n.
Yeah.
So that's what that does. This defines n. But then
So
down
we
there,
need
that gets
the inverse of u.
no.
No.
Nope.
So using this, we need to what?
You need to make a plot of that over a range that I've told you to make a plot over. So you need to know what E Fermi is.
This.
Yep. Which you don't know because you haven't done part 2.
Okay.
Part 2. So until you know how to solve that problem, you don't even know what the range of the thing is that you're plotting.
It's 100 times whatever we get up here.
Yep.
Okay. And this is, what did you say this was in the step?
What did I say? What was?
2b, right here.
Got it. This is where you're going to do the integral. It's either integral in 4 or the integral in 2, using what you learned from 2 part 1.
Okay.
So you have to do that integral. There'll be a single formula that you'll get.
We have to do. Sorry.
You have to do the integral.
Oh my gosh! I wish this was easier to.
Yeah. So there's equation 4 or equation 2. You have to do that integral, and you're going to get a simple formula. So tell me what the simple formula is, and then use it to solve for n as a function of mu instead of mu as a function of n, basically.
Can you say that one more time? I'm sorry.
So this will be much easier after you've done it. Okay. You're going to evaluate n when t equals 0. Yes. And it's going to give you a simple expression in terms of mu at t equals 0, which we're going to call E Fermi. K Fermi is basically you solve for k as a function of E using the E of k relationship. E equals k squared over 2. So that's relationship between E and k. So we're just different names for the same thing. And you're going to see that there's going to be the relationship between E and mu is determined by that formula I give you at the bottom. N of 0 is equal to this k Fermi cube.
So we did the plot of the function, and then we were trying to understand this. Oh, I can't.
The second part?
The second part, yes. And that's also when t is equal to 0, right? Because of this?
Equal to 0 is that function seems to take on 2 values. What are those 2 numbers?
What are you talking about?
Go back to your plot. What does the plot look like?
Step.
Okay. What are the 2? It's stepping between 2 numbers. What are they?
You mean up here, 1 and 0?
Okay. If you were integrating over 0, you're integrating over a region, and if some of that region is 0, do you have to integrate over that? Can you perhaps change the limits of your integral to make your life easier?
So from 10 to 0?
Now go back. Well, that's something you could do. So think about what that would mean symbolically, not necessarily in terms of 10, but in terms of mu, what that would mean. What's on the x-axis there? Is that epsilon or k or e? What is that?
I can't quite tell. It's an e, I believe.
Okay. All right.
Wait, you've lost me. I have no idea what you just said.
I said, all right.
Well, no, before that.
I said, what is on the x-axis label?
E.
Yeah, so we agree. That's E.
Yes.
Okay. So what's your question?
It's doing the integral of this, right?
Mm-hmm. Can you simplify that integral if you know what f is?
If I know what f is? Well, this is f, isn't it?
If you know what f is at t equals 0, f is going to do something special.
It'll just be 1.
Okay, so can you do that integral? Can you do the integral for equation 4 if f is equal to 1 or 0?
Yeah, it's just the integral of g of e, but instead of going to infinity, are you saying it only, well, where'd that go? Instead of it going to infinity, it's only going to 10?
Well, not always 10. It depends on what mu is. So presumably you're going to get a different upper limit depending on what mu is. So what value of mu did you use in this particular case?
10,
Okay.
up here.
Okay. So what would the integral be in general if you didn't have to put in a number for mu? Going back to g, can you rewrite equation 4? So you're integrating from 0 to something. What is the something you're integrating to?